Hey guys, welcome to yet another video on forces. Okay, so we are starting on a brand new chapter right now. So far we've touched on, we've studied motion, how movement of objects take place through acceleration, through speed, or even velocity. We talked about scalars and vectors. So pretty much stuff that we've discussed so far. So right now we're talking about these things, forces, still very familiar to many of you. I'm sure you've heard of these. But basically, what are forces? Okay, let's check out this animation. Let's do this. Okay, as you can see, my two friends here. Okay, one of them is pushing, the other one is pulling as they do it. What happens to the big cabinet? It starts to move, right? So a force is basically nothing more than a push or a pull. Okay. All right, so what happens? What is a unit of force? We actually measure force based on newtons. So 1 Newton is the SI unit for force, and it's basically about the weight of an apple. All right. So what do forces do? What is the effect that a force have on an object? So as you can see, there's a booster here on a spaceship. As I put a booster, you can see it just slows down or it starts to move. So the effect of force will be can change the speed of an object over here. Okay, that's the first thing. Any more things that can happen? Okay, you can see what's happening to the force to the object here as I apply a force. You are absolutely there. It actually forces can change the direction of an object. Okay. And another case, as you can see, we're going to put some boosters on the two ends. Oh, starts to having some G-force training here. So what's happening to this guy? That's right. Okay, you can actually change the spinning or rotation. So forces, you can actually change the speed, direction, rotation of an object. And what else you can do? Oh, you can actually change the shape. So by changing the shape, you can see it's being stretched here. Over here, it is changing the shape also, but it's being compressed. In this case, also changing the shape, just that it's being bent. Okay, the bar is being bent. You can actually change the shape. And in this case, again, you can actually compress it. Okay, again, deforming the object. So similar, changing the shape still. So in a nutshell, okay, so what do forces do? Effect of forces that have on an object. It either changes the motion, the top three here, you can see the motion. One of them is changing the speed, this one is the direction, over here rotation. Or you can also change the shape of an object here. You can see the shapes here is being stretched, compressed, and being bent over here. Okay? All Okay, so now just a quick recall on two terms that we've studied so far, scalars and vector quantities. Okay, so we know force is a physical quantity, but is it scalar or vector? All right. Okay, I think you would have guessed it by now. A scalar actually has only magnitude, vectors have magnitude and direction. So for example, if we add 5 meter cube of water to another 5 meter cube of water, you get 10 cubic meters of water. But what if you add 5 Newton force to another 5 Newton force? Do you get 10 newtons? So it depends, right? So because 5 newtons of force is important of where the direction, where are you going to exert that force? So that's why forces are vector quantities, okay? So just to do a quick recap, how do we actually move? Um, how do we represent force diagrams? Okay, so let's represent a 20 Newton force that acts in the direction of 45 degrees north of east. So how we actually identify is we actually draw to scale 4 centimeters, and in the same direction you can see the orange purple orange G line here. That is the force. You can see it's just basically represented by an arrow. Okay, and the length of the line actually denotes its magnitude. Okay, so addition of vectors, when I have more than one vector acting on an object, you must find a single vector, or also known as the resultant vector that produces the same effect as the individual vectors combined. Okay, what do I mean by this? Okay, so just a quick recap again. Forces. We are right now on the topic of force. Forces are actually vectors, right? So if I have two forces here acting on this object here, a 3 Newton force and a 5 Newton force, both of them are acting to the right. What will be the final effect on the object? Okay, so the final effect is also known as this word called the resultant force. Okay, so two forces, I can replace these 3 Newton and 5 Newton force with one force. Okay, and that force in this case, since they are both acting in the same right direction, okay, I will boom replace those two forces, 3 and 5, with uh, an 8 Newton force over here. Okay, so another case, what if it's opposite? So I find 3 and 5 Newton force here, and they're opposite in direction. Okay, you guessed it. Okay, I can actually replace it with a resultant force of boom 5 minus 3 Newtons. Okay, so 5 minus 3 gives me 2. Does that make sense? Yes, if I'm pulling on to the left, pulling to the right, something like a tug of war, the final effect will be it will go to the part where it has a slightly higher force. Is it right? Okay, a final scenario over here. What if I have two 3 Newton forces? What do you think will happen here? The resultant force will be, that's right, 0 newtons, because both of them cancel out since they're in the exact same opposite direction. Okay, hope you enjoyed this video on forces. So just I'll see you in the next.